Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of engineering chemistry. We'll dive into key concepts like acid number, saponification number, steam emulsification number and related numerical problems. Slide 1. Acid number, definition and significance. Let's begin with the acid number. This is an important parameter used to assess the quality and condition of lubricating oils. We define acid number as the number of milligrams of potassium hydroxide (Co) required to neutralize the acidic components in 1 gram of oil. It gives us an idea of how much acidic material, like free fatty acids or oxidation products, is present in the oil. This is very important because high acid numbers show the oil is degrading or has been oxidized, possibly due to high temperature or aging. Such degradation can cause corrosion in metal parts, especially in engines and turbines. By monitoring the acid number, we can decide when to replace the oil to avoid damage. For example, engine oils that run for too long without change will have a high acid number. Slide 2. Saponification number, definition and importance. Next is the saponification number. It refers to the amount of Co, in mg, needed to saponify the fatty components in 1 gram of lubricant. Saponification simply means the breakdown of fats, oils into soap using an alkali like Co. This number helps us identify if the oil contains animal or vegetable-based esters, or if it is a purely mineral-based oil. Vegetable and animal oils contain esters, so they react with Co and give a higher saponification number. Why is this important? If we know the oil is of organic origin, it may biodegrade more easily, good for the environment. High saponification number indicates that oil might be better for lubricating softer delicate machinery, but it can also mean the oil is more prone to hydrolysis, breaking down with water. It is also a way to check adulteration or blending in oils. For example, vegetable oils used in cutting machines will have higher saponification values than mineral oils. Slide 3. Steam emulsification number, definition and significance. Now, let's understand the steam emulsification number. This number tells us how well a lubricant can form an emulsion, which means a mixture of oil and water or steam. Why is this important? In industries like textiles or paper where machines run in humid or steam-based environments, lubricants must mix well with water to protect machine surfaces and maintain smooth operation. If oil doesn't emulsify properly, water separates out, and this can cause corrosion or metal friction. A higher emulsification number shows better ability to form a uniform emulsion. This is ideal for steam turbines or wet processing machines. Example: emulsifiable cutting oils used in metal workshops can form milky emulsions with water, protecting both the tool and workpiece. Slide 4. Comparison table. Let's now look at the differences between acid number, saponification number, and steam emulsification number. 1. Purpose. Acid number right pointing arrow tells us how acidic the oil is. Saponification number right pointing arrow tells us about the fatty ester content. Emulsification number right pointing arrow shows oil's behavior with water, steam. 2. Units. Both acid and saponification numbers are expressed in mg of Co per gram of oil. Emulsification number is not fixed in units, but usually expressed in volume of water emulsified. 3. What it indicates. Acid right pointing arrow oil degradation or contamination. Saponification right pointing arrow presence of animal, vegetable oils. Emulsification right pointing arrow oils performance in moist, steam environments. 4. High value interpretation. Acid means more corrosion risk. Saponification, more organic content. Emulsification, better performance with water, steam. 5. Use in industry. Acid number right pointing arrow for engine or turbine maintenance. Saponification number, right pointing arrow for choosing biodegradable or blended oils. Emulsification number, right pointing arrow for textile and wet industry lubrication. So, each of these values tells us something unique and helps in selecting the right lubricant for specific conditions. Slide 5. Numerical problems. Let's now go through two simple numerical problems to understand how these values are calculated in real-world labs. Problem 1. Acid number. 10 grams of oil requires 2.5 milliliters of 0.1 NCO. Calculate the acid number. Step-by-step explanation. In formula where V equals volume of CO, milliliter. N equals normality of CO. W equals weight of oil, G. 56.1 equals molar mass of CO. By substituting these values in formula we get. The acid number is 1.4. This is a moderate value, indicating slight oxidation. Problem 2. Saponification number. 1 g of oil requires 5 milliliters of 0.5 NCO. Calculate the saponification number. Using the same formula and substituting the values we get. Saponification number equals 140.25 milligrams CO per gram. This high value suggests the oil contains significant esters or fatty components, maybe of vegetable origin.